Okay, so today we're going to look at solving partial fractions, which I really like, so hopefully you really like, because partial fractions are fun. Okay, so there's really like 4 different cases of partial fractions that we'll look at. The first case is when your denominator is a product of distinct linear factors, meaning that you can factor your denominator easily. That would be the first case. So we're going to look at a couple of different examples of that. The first one we're going to look at is when your denominator is smaller than your numerator. And the second one we'll look at is when your numerator is smaller than your denominator. So if I look at the integral of x cubed plus x divided by x minus 1, first thing I'm going to do is I'm going to do long division in order to be able to divide my denominator into my numerator. So my denominator is x minus 1. My numerator is x cubed. We don't have an x squared, so 0x squared plus x. Okay, so x goes into x cubed, x squared times. So x times x squared is x cubed. Negative 1 times x squared is negative 1x squared. So if we subtract those, my x cubed goes away, minus a negative becomes a positive 1x squared. And then you bring down plus x. If I do that again, x goes into x squared, x times, so x times x is x squared. Negative 1 times x is negative x. And if I subtract those things, x minus negative x becomes positive 2x. And x goes into positive 2x 2 times 2 times x is 2x. 1 times 2 is minus 2. X squared minus a negative becomes a positive 2. And so that is my remainder. So if I rewrite what I have x squared plus x plus 2 and a remainder of 2, so plus 2 divided by my denominator x minus 1. So here's where I get to start doing the fun integration. So the integral of x squared is x cubed over 3. The integral of x is x squared over 2. The integral of 2 is 2x. And anytime you're dealing with a fraction, you pull the numerator out top. A fraction integrates to the natural log. So this would be 2 natural log of x minus 1 plus our unknown constant c. Okay, so when your numerator or your denominator is smaller than your numerator, you do long division. Otherwise, you do what we call partial fractions. So if I look at number 2, I have x squared plus 2x minus 1 divided by 2x cubed plus 3x squared minus 2x. Our first step is to factor our denominators when we're dealing with partial fractions. So if I look at 2x cubed plus 3x squared minus 2x, what can I factor out of that? an x. Thank you, Kira. So if I factor out an x, I get 2x squared plus 3x minus 2. I know that 2 times 2 gives me 4. Factors of 4 that subtract to 3 are 4 minus 1. So this would become 2x squared plus 4x minus 1x minus 2. And if I factor by grouping out of the front, I can take a 2x. And I'd have x plus 2. Out of the back, I can take a minus 1 and have x plus 2. So this whole denominator factors to x times x plus 2 times 2x minus 1. Okay, your second step is to break it into pieces. Okay, so I have a denominator of x. I have a denominator of x plus 2. I have a denominator of 2x minus 1. And then your numerators, in this case, you reduce your denominator by a power of 1. So if I reduce this x by a power of 1, it goes away. So, sorry, my numerators are just constants, which I'm going to call a, b, and c. Okay, there's some unknown number. Okay, so then our third part, now that we have it into our pieces, is to get back to having a common denominator. So if I go back up to my a over x plus b over x plus 2 plus c over 2x minus 1, if I want to have this a to have a common denominator, I need to multiply it by what I have on the bottom, so x plus 2 and 2x minus 1. If I want this b to have a common denominator, I need to multiply it by the x and by the 2x minus 1. And if I want this c to have a common denominator, I need to multiply it by x and x plus 2. Okay, so for now we're just going to ignore our denominators. So I have a times x plus 2 times 2x minus 1. I have b times x times 2x minus 1. And I have c times x plus 2. If I FOIL this, x times x is 2x squared. X times minus 1 is minus 1x. 2 times 2x is 4x. 2 times minus 1 is minus 2. And I still have a outside. If I look at b times x times, if I FOIL this, I still have b. X times 2x is 2x squared. X times minus 1 is minus x. And if I distribute my x to my last one, x times x is x squared. X times 2 is 2x. Yes. Oh, plus, sorry. Yes, there should be a plus there. Okay, so if we keep distributing, I know that minus 1x and 4x combines to be 3x. And if I distribute my a times 2x squared gives me 2ax squared. A times this minus 3x gives me minus 3ax. A times minus 2 gives me minus 2a. If I distribute my b to my 2x squared, I get plus 2bx squared. If I distribute my b to my x, I get minus bx. And if I distribute my c, I get cx squared plus 2cx x. Factor out your coefficients. That's what I meant. Where do I mean for? Oh, yes. Step 4, factor out your common coefficients. So, if I look here, I have an x squared there, and an x squared here, and an x squared here. So if I factor out my common coefficients, I have a 2a, I have a plus 2b, and I have a plus c, all times x squared. If I look for just my x's, I have a minus 3a minus b plus 2c. So plus minus 3a minus b plus 2cx. And if I look at then what I have left, I just have a minus 2a left over. And that is equal to your original numerator. So what was my numerator on that fraction to start with?
X squared
Minus 4?
1.
Minus 1. Okay. So then the last step is to group your coefficients and solve. Okay, so I know that this is like a 1x squared, which tells me everything in front of my x squared. So my 2a plus 2b plus c has to equal 1. Since this is a 2x, everything in front of my 2, so minus 3a minus b plus 2c has to equal 2. And my constants then, which is minus 2a, has to equal that negative 1. Then we solve the easiest ones first. So I'll start by solving for my 2a by dividing by negative 2. So I know a is equal to a positive 0.5 or positive 1/2. Sometimes it's easier to leave them in fraction form. If I then solve this equation for b, I would get b equals negative 3a plus 2c minus 2. And I know that a is now equal to 1/2. So b equals negative 3 over 2 plus 2c minus 2. And I'm going to plug both of those into my first equation to solve for c. So a was 1/2. B, we just said, is negative 3/2 plus 2c minus 2 plus c equals 1. Well, 2 times 1/2 is 1. 2 times negative 3/2 is negative 3. 2 times 2c is 4c. 2 times negative 2 is negative 4. Plus c equals 1. 1 minus 3 is negative 2, minus 4 is negative 6. 4c plus c is 5c. Okay, so we just combine our like terms. So far, so good. Okay, and 6 to both sides. So 5c equals 7, divided by 5. C equals 7/5. And so then we back substitute what c equals into b to solve for b. So b was negative 3/2 plus 2 times 7/5 minus 2. Well, 2 times 7 fifths is 14 fifths. I want to make this have common denominators of 10. 2 is 20 over 10. And so then this would be negative 15 over 10. 14 becomes 28 over 10. Minus 20 over 10. So negative 15 plus 28 is 13. 13 minus 20 is negative 7 over 10. Almost. Now we just get to plug our A, B, and C back into what we had. So when we broke it into our parts, we had A over X plus B over X plus 2 plus C over 2X minus 1. So let's plug in our A, B, and C. We said A was 1/2, so 1/2 over X. We said B was negative 7/10 over X plus 2. We said C was 7 fifths over 2X minus 1. Simplifying that, that becomes 1 over 2X minus 7 over 10 times X plus 2 plus 7 over 5 times 2X minus 1. Yay, and we're finally done. Aren't partial fractions fun?
No.
Yes, they are. They're seriously the best. Okay, so let's look at our second case. Case 2 is when your denominator is a product of easy linear factors, but your easy linear factors are repeated. Okay, so a lot like case 1, except that your linear factors will be repeated, so you might have like an x squared plus 1 squared or something. Okay, so if I look at example 4, I'm given the integral of x to the 4th minus 2x squared plus 4x plus 1 over x cubed minus x squared minus x plus 1. Because my denominator is smaller than my numerator, I would do long division. And so I'm going to skip over all the different steps for that. Mainly because it's a really long process. And tell you that it long divides into x plus 1 with a remainder of 4x. So x cubed minus x squared minus x plus 1. Okay, so the second step is to factor your denominator. So in this case, our denominator is x cubed minus x squared minus x plus 1. Which factors to x minus 1 squared times x plus 1. That's how that factors. Okay, so if we break it into our pieces, I'm going to have a over x minus 1 plus b over x minus 1 squared plus c over x plus 1. Whenever you have a repeated factor, you have to do the factor individually and repeated. Okay, so that's the only difference from part 1 where you didn't have any repeated factors. So that's why I have an x minus 1 and an x minus 1 squared. Part 3 is to work through my common denominators. So in this case, if I want to have common denominators, I need to take this times another factor of x minus 1 and a factor of x plus 1. B gets taken times a factor of x plus 1. And c gets taken times a factor of x minus 1 squared. I FOIL the top, I get x squared minus x plus x minus 1, all times my a factor. If I look at b, and if I distribute my b, I get bx plus b, because b times 1 is just b. And if I FOIL this, I get x squared minus 2x plus 1. So if I keep distributing, I get a x squared minus x. Oh, nope, sorry. Just kidding. Those cancel. So minus ax squared minus a plus bx plus b. I distribute my c, I get cx squared minus 2cx plus c. And that again gets set equal to my numerator, and in this case my numerator, my fraction, was just 4x. When everything was said and done. Okay, step 4 is to group my coefficients. So I have an a x squared and a c x squared, so a plus c times x squared. I have a bx and a minus 2cx. And I have constant coefficients of negative a, positive b, positive c. Okay, and the last step was to solve. So if this is set equal to 4x, what do I know that a plus c has to equal? How many x squared factors do I have in my solution? How many x squared factors live in 4x? How many x squareds are on the board?
0.
There are 0 x squareds, right? You only have 4x, so you have 0 x squareds. How many just plain x's do you have? 4, because you have a 4x. And how many constants do you have? 0. Thank you, Kira. Okay, so I'm going to try to get everything in factors in terms of c so I can solve my last equation. If I solve a in terms of c, if I subtract c from both sides, I get a equals negative c. If I solve b for c by adding 2c to both sides, I get 4 plus 2c. And so then taking my last equation, negative a plus b plus c equals 0. If I plug in what a equals, I get negative negative c plus 4 plus 2c plus c equals 0. Well, negative negative becomes a positive. So if I group my like terms, I have 1c plus 2c plus 1c, which is 4c, plus 4 equals 0. So I get c equals negative 1. Knowing that, then I can come up here and solve for a. If I know that a is negative c, then I get negative negative 1. So a becomes positive 1. And if I solve for b, b equals 4 plus 2 times c, which is negative 1. So b equals 2. What was my denominator for A? When I set up my partial fractions? X minus 1, okay. And my denominator for B? X minus 1 squared, which makes my denominator for C X plus 1. Are you done? Are partial fractions fun? Yes, they are. All right. Case 3 is when your denominator contains irreducible quadratic factors. There's 4, but we're going to do an example for case 4. Because case 4 is just like case 2 and 3 squished together into 1. Okay, so if I look at this inequality, or this integral, I have 2x squared minus x plus 4 over x cubed plus 4x. So, first step is to factor your denominator. My denominator is bigger than my numerator, so I don't have to do any long division. So what can I factor out of an x cubed plus 4x? X. So if I factor out an x, I get x squared plus 4. And x squared plus 4 is not reducible. So we go to step, you can't reduce it or factor it any further. So we go to step 2, where we set up our partial fractions. Now at the beginning I told you to reduce your numerator by 1. So x is just turned into constants. In this case, an x squared turns into an x. So we have bx plus some constant c. You only have to put an x in your numerator if your denominator has a factor bigger than x. Step 3, common denominators. So I take a times x squared plus 4, and I take bx plus c times x. So if I distribute my a, I get ax squared plus 4a. If I distribute my x, I get bx squared plus cx. And that was equal to my original numerator, 2x squared minus x plus 4. Okay, so let me factor out my common coefficients. So I have an ax squared plus bx squared. So I have a plus b times x squared. I only have one regular x factor, so just cx. And I only have one constant factor, which is 4a. Okay, so then you group your numerators. Okay, so if I'm looking at just my x squared factors, then I group them to my x squared factors. So a plus b would equal 2. If I'm looking at just my x factors, I group them to just my x's. So in this case, c would equal -1, because I have -1x. If I'm looking at just my constants, if I group them, 4a groups to 4, which, yes, then if I solved for a, gives me a equals 1. So I already have two of my solutions. I have c equals -1, a equals 1. So the last thing I have to do is solve for my x squared coefficient. I know that a is 1, so that gives me 1 plus b equals 2, which means b also equals 1. So a is 1, b is 1x plus my c, which is -1. What was my denominator for a? Yeah, my denominator for a. Just x, okay. And what was my denominator for bx plus c? X squared plus 4. Okay. Case 4 is when your denominator is both irreducible, meaning you can't factor it out to linear factors, and it repeats. So it's a kind of a combination of case 2 and case 3, because case 2 is when we had repeated factors. Case 3 was when they were irreducible. Do you guys want to look at the example of case 4? Case 4 doesn't happen very often, but it's not a long example if you want to look at it. Yeah? Okay. Okay. So then case 4's example is the integral of 1 minus x plus 2x squared minus x cubed over the denominator x times x squared plus 1 squared. And so step 1 was to factor your denominator, but in this case, my denominator is already factored for me. So I can just kind of skip that step. Step 2 then is to break it into my different pieces. So in this case, I have an x. I have an x squared plus 1, and I have an x squared plus 1 squared, because I have to do each piece. So then my numerators, in this case, since this is just an x, it'll just be a constant. Since this is an x squared, it'll have to have an x factor in the numerator. And since this is an x squared, it also has to have an x factor in the numerator. So I'd have a over x plus bx plus c over x squared plus 1 plus dx plus e over x squared plus 1 squared. So then 3, if I want to get my common numerators, I would have to multiply a by x squared plus 1 squared. I have to multiply bx plus c times x and another factor of x squared plus 1. And I have to multiply dx plus e just times x. So if I free out x squared plus 1 squared, that gives me 2x squared, 2x to the 4th plus 2x squared plus 1. If I FOIL my second one, I have x times x squared is x cubed plus x. And if I distribute my x, I get dx squared plus ex. And then I have to keep multiplying. So a times x to the 4th is ax to the 4th. A times 2x squared is 2ax squared. A times 1 is A. If I FOIL my second set, I get bx to the 4th plus bx squared plus cx cubed plus cx, and I still have plus dx squared plus ex. Okay, so let's factor out what we know. So we have an ax to the 4th and a bx to the 4th. I have a cx cubed, and that's my only x cubed factor. I have 2ax squared and bx squared and dx squared. For my x's, I have c and e. And for my constants, all I have left is an a. And that's going to equal what my numerator of my fraction was, which is 1 minus x plus 2x squared minus 1 minus x plus 2x squared minus x cubed. Is that what my numerator is? X cubed? Okay. So if I start to group my coefficients, I have 0 x4th factors. So a plus b equals 0. I have 1 negative 1 factor of x cubed, so c equals negative 1. I have 2 x squared factors, so 2a plus b equals 2. I have a negative 1x factor, so c plus e equals negative 1. And I have 1 constant factor, so a equals 1. Okay, which tells me 2 of my factors are already solved for. C and A is already solved for. If I then want to solve for b, that gives me 1 plus b equals 0, which gives me b equals negative 1. So b is pretty easy to solve for. If I want to solve for e, I have c plus e equals negative 1, so negative 1 plus e equals negative 1. So e equals 0. Pretty easy to solve for. So the only letter I have left is d. And so in this case, d was 2a, so 2 times 1 plus b, which is negative 1, plus d equals 2. 2 times 1 is 2, plus negative 1 is 1. So 1 plus d equals 2. So d equals 1. Then you plug them back in. So my a factor was 1, negative 1x plus c, which is negative 1, and dx plus e. And now I just have to know what my denominators were.
X.
Okay.
X squared plus 1. And x squared plus 1 squared.
Perfect. So those are your partial fractions. Go team, go. We're going to work on this today and tomorrow. So you're going to do 7 through 20 on page 516.